Hello there, and welcome back to another C# intermediate tutorial with the Stride game engine. In this tutorial, we're going to have a look at the first-person camera. By the end of this tutorial, we'll have something similar like this. With the mouse movement, we will be able to look around with our camera, and as you can see, our camera is this lovely, simple little body with just a couple of cylinders, but we can look around using our mouse. We have some maximum angles that we can look up and down to, and as a bonus, we can also just move around with the WASD keys. As you can see, I've opened up the Start First-Person Camera scene, and let's first have a look at how we can apply a first-person camera. So I've already created this base container entity, which is called first-person character, which in itself is not really anything right now. It's just an empty entity which will contain some scripts in the near future. And then there are some cylinders which represent the character body, if you will. Normally you would have the actual character mesh in here, all sorts of rigid bodies perhaps for your weapons. You would store them here as well. But just for now, just a simple visual representation. And finally, we also have this cone, which is going to represent our camera looking into direction. And let's first talk about how we're going to apply camera rotation to a first-person camera. So for this first-person character, I'm going to add an entity, an empty entity. And this is going to be called pivot. Let's add that to the actual first-person character as a child. And as you can see, I have the camera is currently positioned outside our camera, our first-person character. And I don't want that. I'm going to position this underneath the pivot itself. Our camera script is going to adjust our camera pivot. And that's useful because this pivot is now a completely separate entity. And that means we can position that at any place that we want without it affecting the rest of our first-person character. And that's why you want to split this up into separate components. Now our camera is currently positioned a little odd, so let's fix that first. Let's just position that at the exact same location as our pivot. And notice how our camera also has a rotation of 180 degrees, because if we wouldn't do that, our camera would be looking into a negative direction. And that's another advantage of using this pivot entity here. This is going to keep track of the actual rotation of our camera itself. We're not talking to the camera entity itself. We're just going to leave that alone. So with this setup, now let's start looking into the script for the camera rotation. So we're going to go to Code, First-Person Camera, and let's add a new sync script here. And let's call this First-Person Demo. Let's save this. And let's add this to the first-person character entity. There we go. And now let's go coding. The first thing that we need to be dealing with is dealing with the mouse visibility and being able to switch between camera movement and the actual UI that we have in our scene. This is something that you will have in your scenario most likely as well, because probably when you press escape, you want to show some sort of menu and you no longer want to be actively rotating around with your camera when your mouse is moving over the UI. So let's deal with that first. So we're going to keep track of a private boolean is active. And by default, when we load our tutorial scene with the first-person camera scene, then we want to say, hey, this is now active. And that means that in our update loop, if our camera is active, do the actual camera rotation. So let's place a comment here to do camera rotation. But before that, we want to say if input is key pressed, if that is keys.escape, Then we want to toggle this is active. So let's say is active is no longer active. So we're going to switch between the two. And what we want to do is say game is mouse visible. With this, we can actually turn on the is mouse visible, yes or no. Is mouse, come on, is mouse visible? And obviously we want to, actually, you know what? We can use the is active variable here again, because we just toggled that. And we're just going to say if we are not active, so if our camera should not be rotating around, then that mouse visibility is being disabled. And we also want to be locking our mouse position, or unlocking, I should say. And what this does is as soon as we press the escape key, regardless of whether we want to activate or deactivate, we just want to be giving that mouse availability back to the user again. So it's no longer stuck to a certain position. Similar, if the camera is active, we also want to make sure that the lock mouse position is enabled again. So this is actually happening every single frame as long as our camera script is active, and regardless of whether when we press escape, regardless of whether the menu should be activated or the mouse movement for the UI should be activated is really irrelevant at that point. In our start, we definitely don't want to have our mouse visible, so we're going to say is mouse visible. We could hard code that to false, but let's say the negative part of is active, or the opposite part of is active. So by default, mouse is not visible and our camera rotation is active. Now for the actual camera rotation. How do we do that? Now let's make a public float mouse speed. And this mouse speed is going to affect how fast our mouse movement is going to be applied to the actual camera rotation. Let's also make another private variable called of type vector3 called camera rotation, which is going to have the actual camera rotation value stored in it. So let's give that its base value, camera rotation. Let's give that the rotation of our current entity. So we can say transform dot rotation Euler XYZ, which is the current XYZ coordinates of our rotation. And every time we do any mouse movement, we can add those values to this camera rotation, which we're going to do in our update script. So first we need to get track of that mouse movement. So we're going to make a variable called mouse movement. And we can simply do this by saying the input dot mouse delta, which we multiply with mouse speed to get the proper speed of our mouse movement. And the mouse delta is already taking care of the time scaling, so mouse delta time, which means that regardless of the FPS you have, you will always get a correct or similar value. And the multiplication with mouse speed simply indicates that we have that value that we declared up top. If it's a higher value, then we move our camera rotation, we rotate it faster around its axis. So that camera rotation, let's first calculate its y coordinate. And we simply have to add the mouse movement dot x. And let's think about this for a second, because this may look a little bit confusing. If we move our mouse to the left and the right, then this movement value is stored in the mouse movement dot x coordinate, but we want to rotate our character on the y-axis. And that is why we are storing this value inside camera rotation dot y, or actually we're adding to the existing camera rotation dot y. Another thing, if we are moving to the left and our character needs to rotate to the left, if we would do this in the editor, you would see that this is a negative y direction. So to compensate for this, we simply add a minus character here, and that will solve the problem for us. Now let's apply this rotation that we've calculated to our entire character. So we can say that with entity.transform, and then we have the rotation property here, which is a quaternion. And we have a helper method, quaternion.rotation_y. And all we need to do here is pass the camera rotation.y value into it. And that is pretty much it for the Y rotation. So let's have a look at how this looks. We start our scene, and if we move to the right, well, look at that. Our camera, or our entire character, is moving to the left and to the right. Perfect. Now all we need to do is do the exact same thing with the mouse moving forward and backward, thus moving our camera angle up and down. So we can achieve a similar thing by simply copying this line and swapping out camera rotation Y to X, and for the mouse movement, swapping the X to a Y, and removing this minus character. Or while we are at it, let's also add a property that deals with inverted mouse options. So some people like to have an inverted Y for the mouse movement, so we can say invert Y. Let's set that to false by default. And here we can use a little ternary operator that if we have the invert Y option available, then we want to use mouse movement.y in a negative value, and otherwise let's use mouse movement dot in a positive value. Now, if we are moving our mouse up and down, there eventually will be a point where you start, let's say you're looking down, then eventually you will start to look down your own legs and you will start looking backwards, upside down. That's not really what we want. We want to limit our mouse or our camera rotation.x. We want to limit that to certain angles. So let's add a variable that does that for us. So let's add a public float max camera angle. Let's set that to 50 degrees. And since this is the upper max camera angle, will be in a negative value. And the minimum camera angle will also need to be specified. And the values that we enter inside the editor, those are often in degrees. But since we're dealing with a quaternion here, we need to be converting those values to radians. So let's make a private variable of vector2. And let's call this max camera angles. And let's convert the values that we've entered above. Let's convert those. So we can say max camera angles. Let's use a lowercase max camera angle there to keep consistent. And here we can say new vector2. And in order to convert these from degrees to radians, we can use math.util degrees to radians, and then specify that max camera angle. And we do the same thing for the minimum camera angle. Minimum character angle. There we go. So we've dealt with the invert option. Now we only need to do is say camera rotation.x, and we need to sort of restrict that maximum character angle. Again, we can use the math.util class here. We can use the clamp function. We specify at first the x value. That is the value that we want to have a look at, that there is a minimum and max value. And now we can have max camera angles.x and max camera angles.y. So now we're being restricted between those two angles. So now that we have calculated the rotation, we also need to apply it somewhere. And we're not going to apply this to the entity itself, because then we would also be rotating the mesh, or we would be rotating the character collider itself. We just want to be rotating the camera on its x-axis. And we already created a pivot point for that inside the editor. So let's get a reference to that. So let's make a private entity, and let's call this camera pivot. And in our start method, let's say camera pivot is entity dot find child, and our pivot was called pivot, I recall. And once we have that pivot, all we need to do is apply that camera rotation to it. So we can say camera pivot dot transform dot rotation, as we've done with the entity above, and use that quaternion helper method, quaternion, and this time we say rotation X, camera rotation dot X. Let's give this a go. And if we move our mouse up and down, that's looking good. Our left and right is still looking good. But let's say if we move now down all this way, and this is the maximum character limit when we're looking down, which is great because we can still see our arms and our shoulders, but we cannot look down further and rotate our camera upside down. And the exact same thing goes for the upwards direction. You can't really see that because the sky is entirely blue. We're not seeing anything else, but there's a limit there as well. Now, this tutorial is mostly about the camera rotation itself, but it wouldn't entirely be complete if we could not move our character around as well. So as a bonus, let's add that as well. Let's create a new script, a sync script, and call this player mover. Let's create that, and let's select our first person character, and let's add the player mover, and let's start making the script for this movement. We'll start off with a public vector3 player, let's call this movement speed, which is a new vector3, and let's give it some base values. Let's say that if we are moving to the left, or if we are strafing, then this is a value of 3. We're not really doing anything with the height, but when we're moving forward, we have a value of 4, because when we're moving forward, we're just a little bit faster than strafing. And in our update, all we need to do now is keep track of the WASD keys. Let's make a variable called velocity, which is a new vector3. And in here, we're going to store all the movement that we are doing. So let's say if input is key down, and if the forward key is being pressed, W, or make it any key that you really want to use for the forward direction. If that's the case, then velocity.z should be increased. And let's just copy this a bunch of times. And if we are moving backwards with the S key, then the Z value is decreased. And if we are moving to the left, then our A key is being pressed, then the X value is being increased. And if we press the D key, our X value is being decreased. Now that we have stored the velocity, we also need to normalize it using the normalize method. Notice that this is a void, which means that the actual velocity value itself is already being transformed in with the normalize method. It doesn't return a new value. We multiply this velocity with that lovely movement speed that we've had up top, so that we can influence how much the player is actually moving when we are pressing those keys. But of course, if we are looking into a certain direction and we're pressing the forward key, then we also want to apply that velocity into that direction, and not just the, let's say that we're pressing the W key, then we would have a value of 1. We do not want to apply that directly on the Z-axis, but it needs to be transformed into our look direction. So we can simply say the velocity is going to be vector3 dot transform, and then we need to have the velocity value that we already have, and we need to transform that with the rotation of our entity. Now, luckily, our entity is being rotated by our camera script, so the direction it's looking at is already applied to it. So all we need to say here is entity.transform.rotation. Now, let's see how we can apply this velocity to our character so that it actually starts moving. And we can make use of an existing component that comes with the Stride game engine. For this, I'm going to go back to the editor. And I'm going to click Add Component. And then I'm going to search for Character. Once that is applied, you can see that we have a character rigid body attached to our entity. And this is a really special kind of rigid body because it contains various extra properties. Among those properties are, for instance, the step height. If our character is moving and it comes across a sidewalk or some stairs and they're really low, then our rigid body, or this character rigid body, is going to automatically step on this particular object. There is the maximum slope setting. If you have a steep slope, then you do not want to be able to access this slope or walk on this slope. And you can set that with this maximum slope setting. We also need to provide a collider shape. So let's, by default, the capsule is a really good option. Let's look at how this capsule is currently looking. Guess I have to enable the physics for this. Notice how the character collider component is a pinkish color and it's currently inside the floor. So if I select this object again, I have to give it an offset. And now, as you can see, our pink collider here is active inside the scene and it's somewhat covering our player with this pinkish capsule. So that's looking good. Now let's retrieve a reference to that inside our script that we've just made for the movement. I'm going to make a private variable, private character component, which I have to include with using stride.physics namespace. Let's call this the character. And in our start method, we're going to say character is entity dot get character component. And lastly, all the way down here, once we've calculated that velocity, we can say character, and there's a method here available called setVelocity, where we can apply that velocity that we've calculated. Now, you don't have to use the character component. You're more than welcome to use your own velocity calculation or your own rigid body types. However, do note that the character component that comes with the Stride engine already has all these extra properties set up, and it's already taking care of so many physics interactions for you. Now, last but not least, if you are using this character component, there's one slight change that we have to make inside our first person demo. And that is, instead, we want to be applying this to our character component, because our character component is taking care of an internal orientation value, so where it's looking at to determine the velocity. And since we're applying the velocity on that character component, we have to set the rotation to this character component instead. So we have to include a reference here to our character component. And we'll have to retrieve it here as well. Character is entity get character. And then all the way down here, instead of entity.transform.rotation, we'll say dot orientation is this rotated Y that we've calculated. So let's give this a spin. And if we do first person camera, if we press the WASD keys, we are now moving forward and to the right and to the left. And there you go. We now have a first-person camera controller ready to go and be used in your projects. We'll also be using this first-person camera script for the next tutorial, where we cover a third-person character controller, which uses the first-person camera controller as a basis. See you around for the next tutorial.